Welcome to our HP Tuners live training session here with our Datsun Z car with an LS7 swap. Now, in the last video, we went through the calibration file and we made sure that everything was correct and all the details were programmed right. So when we started up in this video, we're gonna have a successful calibration process. Now, we're gonna be focusing on making sure the injector data is programmed correctly, because in the last video, we weren't sure exactly what data to use. We used the DW data to populate all of our injector tables, but that doesn't necessarily mean that the data is going to be correct because we don't have the brand or exactly what this injector is going to be at. So we're going to be taking some guesswork here and learning how to properly calibrate without injector data in the video. We're also going to be taking a look at taming the idle control. This has a really large cam in it. It's going to be difficult to idle, so I'm going to be showing you some tips and tricks in order to get your idle control sorted out. So we have a lot of things to cover. Let's jump into our live training session here so we can get started. Welcome back to our live training session here with our LS7 swapped 280Z. Now in the last video, we created our base calibration file. We updated everything in that initial file that we did the read out of. We converted it to a 2-bar operating system, and we're now ready to get the engine fired up and start our calibration process. This video, we're going to be focusing on making sure the injector data is going to be accurate. We're starting with injector data that may not necessarily be the correct data. So we're going to learn how to modify that data in order to make sure that our idle airflow is being reported right from our dynamic airflow channel, and then also making sure that the idle control is going to be sorted out and we're going to have a relatively stabilized idle. This does have a big cam, and this will be a little bit more challenging and difficult to make idle compared to an engine with a smaller cam or a stock cam. So when you're working with a large cam car, you will spend the majority of your time doing your idle control tuning. You'll find that full throttle tuning super easy, part throttle tuning relatively easy. Idle control tuning can be a bit difficult and a bit tricky. Now, I went into the VCM scanner and I've created some custom channels here in order to start to take a look at some of our idle control parameters. I have noticed on this particular PCM that I have more channels for the idle control compared to when I did the initial Gen 4 training course last year, or maybe 18 months ago or so. I've found that I can actually see what the proportional integral terms that are being applied into the closed loop idle control feedback are doing. So some of what we talked about and looked at within the Gen 4 training course is going to be applicable here, but I'm going to be trying to introduce some new ways to work with the idle control because we have some new parameters and PID channels available in our VCM scanner, which can shed some light on what's going on with the closed loop control. Before, we were left a little bit in the dark. Now it looks like there is some more channels in here. So I don't know if it's going to be across the whole range of the Gen 4 ECMs, or it's going to be just focusing on this particular PCM that I'm working with here, but I'm going to try to take advantage of it. So hopefully you'll be able to use that and follow along on your particular application. So if we go into our VCM scanner here, I have it opened up. I have my channels list here that I'm going to be working with. Now, this particular channels list, we're going to be focusing in on working with idle control tuning and the mass airflow and getting that calibrated. It's not going to be taking a look at doing any kind of spark tuning or any kind of knock retard. We're going to be leaving that into a separate video. So this channels list, I'm going to have in a downloadable folder that you can grab right into the course directory that you're able to work with. So you can follow along exactly what I have here. You don't need to try to replicate it on your car, which will save you some time. We do find that this master layout list here, so the master layout that we've developed from the Gen 4 course, that's also available in the course directory. I'm going to be making some tweaks and changes into this particular layout here so that it represents what I'm going to be showing right now and how we need to set up looking at our wideband sensor. It's something we haven't talked about yet in the Gen 4 course, and I've had some questions on this, and I want to make sure it's very clear in this video of how we work with EQ ratio. So that's what we're going to be starting off with here, taking a look at setting up in our VCM scanner. So let's talk about EQ ratio and why it's going to be important. EQ ratio is going to essentially be our command lambda. If you're working with your petrol gas air fuel scale, if you're looking at a typical wideband, it'll read anywhere from normally 10:1 to 20:1 air fuel, and that's in the petrol gas air fuel scale. Now, if you're going to be running something like ethanol or methanol or a different type of fuel, you're going to find, or a different ethanol blend, you're going to find that it's going to be registering a different scale, or should be registering a different scaled amount, but your wideband will be reading the exact same scale on the petrol gasoline air fuel scale. It's always a little bit confusing. So what's actually happening when we're taking a look at a wideband is that the wideband is registering in units of lambda. 1.0 lambda is stoichiometric on any fuel type you're working with. Doesn't matter if it's going to be a petrol fuel, doesn't matter if it's ethanol, methanol, propane, whatever it's going to be. 1.0 lambda is stoichiometric for that fuel type. And then as we go up or down in our lambda values, if we go to 0.9 or 0.8, that's going to be getting richer. If we go higher in our lambda values, 1.1, 1.2, that's going to be getting leaner. Now, we don't need to know the specific scale for the fuel that we're working with. So for example, if we're talking about something like ethanol fuel, so we're looking at E85, we'll find that stoichiometric on E85 is going to be approximately 9.7, 9.8 to 1. Now, if we go richer or we go leaner, we'll find that the values will change. I don't want to have to memorize going between all kinds of different fuel blends or different fuel types. I don't want to have to go and memorize the individual stoich points and all of the appropriate air fuel scale for that fuel type. That can be really confusing. That's where lambda is going to be really nice. So all wideband sensors, even your factor narrowband sensors, register in units of lambda, then they convert into units of gasoline, petrol, air fuel scale. When we're working with a parameter called EQ ratio within our VCM scanner, that will be then working with units of lambda. Why this is really nice is that if I go in and I'm working with, let's just say, a flex fuel tune, and I'm finding that my flex fuel amount is going to be varying, and we'll find that the commanded air fuel associated with the ethanol fuel scale will be something that we're probably not familiar with. So if we're looking at what our actual air fuel is and we look at what the commanded air fuel is going to be, it's not going to make any sense. It's always going to have some odd value in there. So working on our EQ ratio and EQ ratio air allows us to go and tune our fuel tables looking at units of lambda, and we don't have to think or know anything about the different conversions going on with the different fuel types. So it's actually really simple to work with. What I'll do here is go into my master list here. I'm going to go down where I have my air fuel ratio commanded. I'll put it right here, right into this separate section. We can see there's a blank point here, an open point. There's no channel being selected. I'm going to start to add in some information. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.